Obviously, we've been talking about mitigation potential, but what are the real world constraints? What is the actual capacity, and what are some of the factors involved? So you can think of climate mitigation potential of these terrestrial ecosystems or land biosphere as biological or theoretical potential, technological potential, economic potential, ecological, and then realistic potential when it comes to actual implementation. So a lot of the future scenarios that rely on big role for BECS, for example, uh, have to worry about what is the actual potential for accomplishing those to meet the targets of global warming with whatever probability. Okay, so that has to be a serious concern. So looking in a simple schematic way, if you think about tons of CO2 equivalent that you want to remove from the system as an abatement per year, there are things called marginal abatement costs. So you can think of abatement cost is the cost of reducing environmental negatives such as pollution, in this case greenhouse gases. Marginal cost is an economic concept, of course, that measures the cost of an additional unit. So marginal abatement cost in general measures the cost of reducing one more unit of pollution. So if you invested to reduce uh, 10 tons of CO2 equivalent and then you want to up it to 11, what is the marginal cost? Sometimes there are scales of economy involved which makes easier to add another unit once investment has been made already in terms of fixed costs, let's say, of setups needed to take out CO2 and so on. But without going into detail, that is going to depend on the price you're going to put on carbon as well. We talked about the social cost of carbon before, which is the socioeconomic impact of an additional ton of CO2 that is emitted. We talk about additional ton, as I said before, because there is a background level and you are adding one more unit of CO2 to the system, and you have to understand how much that additional contribution of CO2 is going to have an impact on socioeconomics. So this is looking at the global economic mitigation potentials for the various sectors at three different carbon prices. Okay, as I said before, if you don't remember, as you increase the carbon price for emission, the motivation for reducing the emission goes up. If the price is too low, which has happened, by the way, in terms of carbon permits that were sold in Europe, California, for example, has put a price where the trading of the permits cannot drop the price below a certain floor. It can go up, but it cannot drop below. So that puts a minimum price on carbon. And these things are good economic and policy tools to bring about the mitigation that we are looking for. So this is looking at less than $20 per ton, less than 50 and less than 100 per CO2 equivalent actually. And this is looking at the transport only for the entire world. And you can see that there is not much change with the price, because whatever you're going to accomplish in terms of contribution of transportation sector to global economic mitigation, you're going to accomplish at basically less than $20 per ton of CO2 equivalent. So the price does determine the economic mitigation potential, but it also depends on the sector. So here is energy, buildings, industry, agriculture, forestry, and waste. Waste is quite small. Already it's there are other factors that is not being considered here. So you have to be careful. If you cannot think of just emissions from waste, you have to think about contamination of soils, of water. So it's not a life cycle analysis here. So you have to be careful. And it is looking for different groups. So these are economies in transition, Organization for Economic Cooperation and Development, so basically the rich countries, and the non-OECD and non-economies in transition countries. The main point, of course, is as you increase the carbon price, the economic mitigation potential goes up because there is a higher driver for reducing emissions. And you can see that buildings have a long way to go, and the change can occur even at $20 per ton CO2 equivalent. So as guzzlers of energy, buildings obviously have some contribution to make. Industries, the difference is high, going from 20 to 50 and 50 to 100, because industries need extra motivation to choose between profits and paying a fine for carbon emissions versus price being so high that they will be motivated to actually reduce the emissions. Right? You can make technology changes, you can do various other things to reduce emissions and balance profits, but those options have to be considered in detail. Agriculture also has plenty of potential for economic mitigation. Forestry, and as I said, waste is over there. The other minor point we have to consider is that the profits or mitigation benefits can accumulate over time. It's not like a one-time step event that you do something for mitigation and it's done. Right? So you have to look at the years after planting, how forests, for example, take up carbon. So this is looking at carbon stock and avoided emissions in terms of petagrams carbon per hectare. So looking at emission reduction, products in use and in landfills, biomass, and benefits to soil. So you can see that soil benefits are accrued fairly quickly and don't change much over time, other than these variabilities that are intrinsically there. And these benefits from biomass, products in use, and emission reduction do increase over time, especially the emission reduction. But the question is, how do you actually meet this potential? As we saw before, forest potential is high, but to keep the carbon and continued emission reduction, you need to protect them from disturbances. A lot of the emissions from tropical forests have made forests positive sources of carbon because of perturbations. So that's a critical factor one has to account for. Reducing the risk for perturbation. This is going to be critical as well. So we'll come back and look at how the global agreements are working and what kind of opportunities and priorities we have to worry about when it comes to land biosphere in climate mitigation. Okay, just a range of issues, but keep everything in mind. As I said, the broader the knowledge base you have, the easier it is to drill into the details of any particular avenue you are going to be taking or have to take.